Okay guys, so today's video, it's not sponsored by UT Source, but they sent me a t-shirt because I asked for one. So they're the guys that I'm always buying these microcontrollers from, all the obsolete stuff, and you guys are generally wondering where I get them from. So yeah, a lot of the obsolete chips that I buy them from this company. I like them because I've had good experiences with them. So yeah, I asked for a T-shirt because I needed to name drop them on the channel. I didn't want to ask for sponsorship. I didn't want money out of them, but I was like, you know what? I like these guys. I like free shirts. So hey, send me a free shirt and I'll wear it for the channel. And so in this video, I'll be replacing this microcontroller. Yeah, this one with a hole in it. But stick around for the whole video because it's actually, there's some interesting stuff in here other than just another microcontroller replacement video. I've done a couple of these videos now, but I played around with some other stuff, played around with some of the other features of the jlink in this one, just stuff that I haven't done before, and thought it'd be fun to give it a try, especially because I wasn't sure if this board was repairable, which is why we're recording the intro with the microcontroller off. I didn't want to put a ton of effort into making a video on this. I'm like super busy still right now, but was just like, oh, this one's gonna be neat because there's a hole blown in the microcontroller. Let's see what we can do with it. Yeah, and this one's also got a little cautionary tale in it too. So yeah, let's get into the video now and just take a look at it. Let's agree that if we're gonna mail a circuit board of an instrument cluster, we're not gonna mail it in a a bubble mailer. Not appropriate. And I don't think my mail person likes me anymore because of this. I guess the little steel pins were poking out the front, so they left a note on it. They actually used one of the little boxes that they use for mail and put it inside there and put it on the porch. So yeah, we'll take a look at this. And this one's full of goodies, but luckily, looks like the screens did not break. The oxygen indicators are good on them, but the stepper motors didn't fare quite as well. So looks like four out of the six of them are bent. They probably still function, but they'd need to be straightened out. So yeah, this is definitely don't ship them like that. So let's take a closer look at the circuit board here, and I'm sure y'all can see where the volcano erupted out of this one. Yeah, I did open the package beforehand. As you could tell, it was ripped open, but I haven't really pulled it out and taken a good look at it yet. This is kind of the first overview of it. Definitely can see where the person mentioned when they messaged me about it that they were trying to install LEDs the when it let out the magic smoke here. So definitely can see where they were trying to put on LEDs. They seem to have changed every single LED also. So even their air lights were going to be like a purple color, I think. I don't know. I don't know what color these actually are. But we're missing LEDs there. I guess they were planning on finishing it when they get it back. I'm going to have to message them and see what the deal is with the lights. Missing a pad here, I see. Yeah, so yeah, let's give this thing power and just see what we get out of it. So zoom that back out a little bit. All right, let's get the clip. All right, and let's hook it up to the power supply and see what happens. There, so we have some lights, and oh, we're pulling 1.3 amps. Let's see. The microcontroller doesn't seem to be getting hot. That voltage regulator is warm. That one's cool. So whatever it is, it's on this circuit. Let's see what voltages we get. Alright, so 5 volts and 1.7. So yeah, definitely something giving a nice strong pull on that one there. I'm not seeing any dead shorts, just glancing at it. But yeah, I'll definitely have to look. Oh, I mean, the short's probably in the microcontroller. This voltage regulator does the power for the stepper motors. I'm not seeing any solder blobs on the back either, just first glance. So, let's get the microcontroller off and then see what the kind of pull we're getting here. I'm reluctant to put another microcontroller on this board just because, I mean, there's got to be cut traces here and here. Well, let's take a look at it under the microscope and see. These two just look like there's got to be some cut traces around them. Okay, so I already glanced over it real quick, but let's take a look at it under microscope. So, yeah, this is where I was concerned it might be a cut trace. It doesn't look like it's actually cut. Definitely have some exposed copper here. Let's take a look at the other one that there may be a cut trace at. So this one is the other one, and again, definitely exposed copper. Probably not actually cut traced here. And let's take a look at some of this, some of these LEDs on here. So, that LED's probably seen better days here. That's not even the one that I was trying to find. Yeah, there's that one. Let's take a look at, here's another one. Oh, overshot it on the camera there. There we go. Yep, definitely LED that's seen better days. So, yeah, not sure that we actually have any cut traces on here. All right, so let's see if I can get it to do this again off camera. So I've been kind of abusing this board a little bit off camera because I'm not completely convinced that this one's savable. I'm not 100% sure that I'm not going to put another microcontroller on here and just fry it. So just out of curiosity, I dug out where it fried the board and gave it power, and it actually sort of turned on. So let's see if it turns back on again. Yeah, there we go. It turns on. See? This is actually working because you'll see that yep, logic is actually functioning. Part of this microcontroller is working. Now I got to turn it back off because it's still pulling a whole amp and getting this guy nice and toasty, so I don't want to fry it. But yeah, after digging out all the char in there, this is a partially functioning microcontroller. I'm really impressed. I could probably take this voltage regulator off and actually salvage the flash memory off of here. It'd actually be kind of interesting to voltage regulator off. Let me do that, just for fun. Let's take this off and JTAG into this and see what we get off of it. If the flash is all completely intact, which it probably is. What I've done is I just lifted the 5-volt output of this regulator here just to eliminate whatever that short was. So now we're only pulling 0.339 amps, so 339 milliamps, which is still a hair high for it, but not horrible. So let's go ahead and just target manual program, read back entire chip, and yep, accept. So it read the whole thing back. So we'll save this. Okay, so I couldn't really find much else interesting that I can do with my EDU version of the Sega jlink because I don't have $800 to spend on the full version, so I don't have all the features. So I can't easily do boundary scanning. You can write custom scripts and do it, but the graphical interface it's not available with the EDU version. But what I can do is pull up Sega JMem, which lets you just kind of watch the memory in real time. So I have it refreshing every 200 milliseconds. And yeah, so I'm using the datasheet for a different chip just because I can't find the datasheet and haven't run into a situation where I actually needed the real datasheet for this chip. This other chip is similar enough the memory mapping and JTAG's all the same for it. So I just haven't bothered to email ST and ask for the actual data sheet for this one, because this one's an off-the-shelf chip. So they should be willing to give you the data sheet for it, even though it's a very old microcontroller they don't produce anymore. So yeah, the memory map's the same. So we can pull up in JMem and just kind of watch the RAM go here, and you can interface with it and make changes. So like we can see if the screen was working, I'd be able to actually change what it's reading here. So we could like um, FF that and change it. Oh, see, and that's actually what's being output to the screen here. So we can actually view that just by swapping through there. So that would be what's being displayed on the screen at this time, and you'd actually be able to change what's going on there, which is kind of neat when you can actually start playing with the memory, which is just one of the really powerful, cool things about JTAG in general. Same with the single wire debug and stuff like that. You can really get in there. So it would make a lot of sense for somebody like me who's getting more and more interested in embedded stuff to actually learn how to use these tools. But yeah, let's actually get into the point of this video, get into repair, and stop messing with this guy's instrument cluster, because this is somebody else's instrument cluster. I really should not be messing with it, but I just, I wasn't convinced that it was fixable, and since this microcontroller is definitely getting replaced, there's a giant cavity in it. I figured it was worth playing with a little bit here. So, yeah, let's get into this. Let's get this thing off the board. Take a look at it. See if we once we get it off the board, we'll put this leg back down. See if we still have a short somewhere, and see where we go from here. Okay, so I got the microcontroller off. I'm thoroughly impressed that something that has a visible hole all the way through it. Let's see if we can focus here. Pretty well impressed that something you can see clear right through, has a hole all the way through it, was actually functioning at all. I'm sure that the die must be like right here, and just barely missed the die and only got the bond wires for that to happen. Um, so I did actually lift one pad, removing this microcontroller, as you can see here. Not a big deal though. All I gotta do is run a jumper to fix that. It happens. These ones, not to make excuses for lifting a pad. So I mean, it happens. You just have to know how to recover from it. Um, but yeah, these ones are pretty tricky to get off because it's hard to feel when it's done because there's so much adhesive underneath it. Also, before I removed the microcontroller, what you saw me putting on there was it's low temperature solder. So it's a chip quick low temperature solder for removing chips. So always whenever you use that low temperature solder, come back and clean it up with some solder wick. I already did that. I didn't show it just because no need to actually show cleaning it. But yeah, I cleaned it and then came with a foam tip and cleaned off all the flux residues. That way I can sit down the new microcontroller on it. But yeah, if you lift the pad, don't stress out. As long as it's only one or two lifted pads, it's pretty easy to recover from. Anything more than two can be pretty tricky to recover from because it just gets really hard to line everything up and start doing it. But yeah, we have one slightly lifted pad right here. It's just this backside of it, or well, this side over here that lifted on it, and it's a ground that comes this direction, so it'll still have continuity and work fine. And then this trace that's floating right here will be what I connect to. So I've done a couple of videos on putting the microcontroller on, so I'm going to get it on here, and then I will show running that jumper instead of putting the whole microcontroller on. So let me get the microcontroller on, and then I'll do a little recording of putting that. Okay, so let's start with trying to get onto the pin of the microcontroller first, and then we'll run to the VM. I already tinned my enameled wire here that I'm using. Alright, and we are connected to the microcontroller. Alright, so we have a good connection to that pin. Let's take a little defluxer and clean around it real quick. Yep, we have a good connection there. So now let's grab the Kimtech wipe and dry up the area so that way we can put down some UV cure solder mask just to hold this in place, and then we'll wire up to the VIA. So let me find that UV cure. There it is, and put just a little bit of this on. I like to use the back of the swabs to kind of put this down with. So just use my finger here to push a little bit. All right. Nope. And we will just dab. It's a little bit more than I wanted around the area. Let's clean that up some. Sorry, I'm zoomed in too much to do what I'm trying to do here. Zoom out so that way I can actually see what I'm doing. Should be good enough. Okay, so we got just a little bit of that solder mask on this pad here. Really not a big deal, but I'm just gonna do a little scrape there so that way if anybody had to do a future repair here, they still have easy access to it. So there we go. That got that excess solder mask off. So yep, we have that relatively cured. Let's get the thing over here. And I really wanted to show a new trick in this video for you guys where it makes it really easy to inspect the pads of this microcontroller, because GM or Yazaki, whoever actually manufactured the circuit board, actually put a UV mask underneath the pins, so that way when you light it up with a UV light for inspection, you can really easily see see if you have a solder bridge or something. But unfortunately, this microscope camera I have really captures UV light way too bright, so I'm not going to be able to show that. But let's get to this pad over here. So you can see this via right here. I already scraped away the solder mask from it. We're going to just run this cable over to it and solder it down. So the point of that solder mask that we put there was to pretty much permanently glue that in place, so that way vibration and stuff, our jumper cable we've run here doesn't break free from the microcontroller and cause problems in the future. So I really should have pre-tinned the pad here before I started recording, but we're here now, so let's we'll just work with what we got. I know a lot of people sand away the enamel first on this enameled wire, but heat works too. There we go. Got it on there. Let me grab my tweezers. And that's all there is to running that. So remember, enameled wire is insulated, so we really don't actually have to worry about it shorting against anything, and that soldering it like that breaks free the uh, enamel on there. Let's just scoot this just a little bit away though. Alright, and we'll just clean that up and that should work perfectly. Alright, so let's power this thing up and program it and see if we let the magic smoke out of this new chip. It is programming. Alright, now it's booting up. Okay, well, I just started editing the video and realized that the camera wasn't running in the last scene, so this little box just said no signal. So here, let me just give you a power up so that way you can see it working. These things take time to boot up. And there we go. We booted up and it's working. Screens are working, the motors were functioning, and these two motors were bad, so I removed them from the board. But yeah, everything works now, so it is a working instrument cluster. I did try writing to the RAM with the jlink in there. And I guess it just refreshes too fast. Wasn't able to actually see it because I'd write to the RAM and then it would change it back. So, wasn't able to actually do what I was wanting to do to it. But I'm sure playing with the RAM some more, I could do it. I just really just don't have time right now to be messing with stuff like that. But definitely in future videos, we will revisit playing with the RAM on one of these because you can mess with that, and you can also mess with like the SPI connection going through it and the CAN connection, stuff like that. So I mean, there's definitely something interesting to be done there. I need to learn how to do it before I can really show it, and I don't have time to learn it right this moment. So yeah, these two stepper motors were bad. This one straightened out relatively good, and I think this was the other bent one. It straightened out pretty good. I messaged the owner of the board, asked him, hey, do you want me to replace these motors? He said no, he has more. I asked him about the LEDs. He said he was going to do them when he gets it back. So I guess he is getting started working on instrument clusters. I'm not completely sure what the story is there, but yeah, it is now a functioning instrument cluster. Um, so I'm happy with how that went. Definitely was surprised that we were able to salvage the data off of the the old instrument cluster, well, the old microcontroller, and surprised to uh, I was surprised that there wasn't a short somewhere, like a permanent short somewhere on the board causing problems. I really was kind of figuring there was an exposed trace that was shorted that I wasn't seeing. But yeah, everything turned out fine. So sorry for my editing mistakes, or well, recording mistakes in this video. I just, I'm still. If you didn't watch my previous video, go ahead and watch it. You'll see, I'm just, I'm really, really busy at the moment. But I thought this one was worth making a video on. So don't give the owner of this too much of a hard time. He was clear that he's just now getting started with this. I mean, he's trying to learn. We all start somewhere. Definitely needs to work on some of the soldering techniques. It might be his soldering iron that's his problem. I If I had to guess, he's using a conical tip with like a Weller soldering iron or something like that. Probably should move to a J hook or a wedge tip, and then move to like a T12 station, a TS100, TS80, something of that nature. Just a little bit better of a soldering station, and there's clearly been like no flux at all used, so needs to work in some flux on there. Those are kind of my critique on trying to improve how this goes for future repairs for this, up and coming technician, learning technician. I don't know how you want to word it, but yeah, it is what it is. It broke. He recognized it was something above his level to repair, sent it to me. I really would have liked it if he had sent the LEDs, so I could have just got them on there for him and this been done. But, it is what it is. Customer wants what the customer wants. So, hey, I hope you guys enjoyed the video, and I will see you guys in the next one.